Basically, what the use scenarios cover is how and why will a component be used. It's one of the things to think about in that is also, in addition to how and why it will be used, is how will it not be used and how should it not be used. Identifying assumptions and dependencies. The dev team is responsible for collecting information about things like external dependencies, implementation assumptions, security notes, any sort of information, security-related information for third-party components that are used as part of the application. When looking at external dependencies, what is important here is documenting the security of the other systems that can affect the security of the system that you're working on. In a nutshell, if you're depending on something that's vulnerable and that's an integral part of your application, you're vulnerable too. Implementation assumptions are important to gather as part of this because they are what developers keep in mind as far as security, designing the security of an application goes. If it's assumed that an application is going to require transporting data over a public network, then obviously the security requirements are very different than transporting totally non-sensitive information across a customer's own network. Modeling the system. Modeling the system is where you get Visio out and start cranking out things like data flow diagrams, visual representations of how the system processes data, what your process boundaries are, what the different components are, and how they talk with each other. Having a clear, documented understanding of how does this application interact not only with other applications but within itself is critical to maintain the security, because if you don't have a firm grasp of what an application does, it's possible that it's doing something you're not aware of and are not taking into consideration in mitigating risk. Some of the questions that you want to answer out of modeling your system include things like, how are protected resources affected? If somebody does nasty things here, what is the risk over here? Where could an external entity manipulate an asset? How deeply can somebody reach into the system? An example of that is the classic SQL injection. A user from a remote internet user is reaching not only to your web server but into your database server. What processing occurs beyond an entry point? What happens to input from a user once it enters the realm of the system? Is all data boundary checked prior to being brought any further into the system? What action is taken on behalf of the external entity? what types of things can a user request initiate? Something that may not be obvious to a user, they may not even realize it. Just a simple example of, let's say you have like a Flickr site, for instance, and you're going and you're uploading your pictures. Most people aren't going to think that when I upload my picture, I'm writing something to a file system somewhere. If the Flickr folks hadn't thought of that, I'm sure somebody else will think of it for them. One final question to answer as far as modeling the system is, what transformation is performed on the data supplied? What this speaks to is taking input from a user, and are we putting it into a buffer? And if we're putting it into a buffer, is that buffer sized appropriately? Is there a risk or a potential for a buffer overflow to take place because we're trying to put too much information in too small space? Identifying threats. After you've cataloged your entry points up front there, what you do at this stage is to look at the entry points and determine how might somebody try to do something here. What might they try to do? Obviously, you're going to have very different thoughts on that within a form in a web application. For a public-facing website that users are putting information on that they're not authenticated first, versus an extranet application that is exposed solely to business partners that has strong authentication required to access it. Your security requirements are very different in each case. The one way of classifying the threats is by breaking them down into general classifications. One way of doing that is the STRIDE model. STRIDE is an acronym standing for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. Some attacks cross multiple, or some attacks fall into multiple categories, but the STRIDE model provides one way of cataloging vulnerabilities. After you've identified threats through the threat modeling process, you can begin to analyze them to see what needs to be done to mitigate them, whether it should be done, and what are the risks if it's not done. Threat modeling provides you a means of quantifying in a very firm way what are the risks and what can happen. One of the underlying thoughts of threat modeling is that things follow one another. It's impossible to have a threat without an asset. So therefore, threats and assets are linked. And in fact, within threat modeling, you use numerical identifiers to link them to one another. After you've cataloged your threats, you create threat trees. Threat trees are what you use to determine the vulnerabilities of a system. Threat trees can take a threat and decompose it into testable conditions. If I do this, then I should get this. If I do this, then I should not get this. It's the threat tree where you break your threats down into the condition checks. Threats within threat modeling are classified by an acronym called DREAD. Damage potential, reproducibility, exploitability, affected users, and I'm going to have to cheat here, discoverability. Basically, by looking at each of those 5 pieces of information and assigning a value to it, typically low, medium, and high, what it gives is the ability to determine what is the risk of this threat. And if this threat is not mitigated, what happens? What's the exposure? An unmitigated threat is what becomes a vulnerability. Keys to threat modeling success. There are a number of recommended best practices as far as threat modeling goes. One of the most universal ones is start the process early. Threat modeling relies on gathering information and pulling it together. If you are gathering that information all along in the process, it's a lot easier than scrambling to find it and hoping you didn't miss anything. By doing it early and continuously, you lessen the chances of overlooking any critical pieces of information. By meeting on a regular basis, you keep security in the minds of the project team. Without meeting on a regular basis, what tends to happen is that security slips by the wayside, is forgotten, and at the end, prior to implementation, everybody starts running around trying to figure out what do we need to do, what do we need to do. By meeting regularly throughout the development process, you can hopefully bypass that last-minute fire drill. By including people that have security background but don't necessarily have an in-depth knowledge of a system, it allows you to get a second opinion. They don't have, they're not so close to the situation that they're able to overlook things that, they see things that people that are deeply involved may not see. Documenting offline is something that's important. Threat models for a complex application can reach into the hundreds of pages and have dozens of diagrams and drawings. It's not really an efficient use of anyone's time to be sitting in a meeting creating Visio drawings to insert into the threat model. It's important to update parts of the document during the meetings by including notes within the living document as you're meeting about it. It allows you to not forget something that came up. Again, you're not supposed to sit there and dutifully note everything and spell check and grammar check everything, just enough to jog your memory when you're going back to actually complete the threat model document. There are some parts that should be done prior to any meetings, though. Things that have inputs from information gathered since the previous meeting should be completed before the regular meetings so that